In this video, we're going to learn about the unit circle. And unit circle is a circle with radius of 1. So I have drawn this circle over here. This is a unit circle, and the center of this circle is this origin, and the coordinates of the origin in coordinate axes are 0, 0. The x coordinate is 0 and the y coordinate is also 0. And since the radius of this circle is 1, so the distance from the origin up to the circumference, up to the point on the circumference, this point is going to be 1. And similarly, the distance from this point up to this point on the circumference is also going to be 1. So this point over here is going to be 1 more than the x coordinate at this point. So the coordinates of this point are going to be 1, 0. Similarly, the coordinates of this point are going to be 0, 1. The y coordinate would be 1 greater, but the x coordinate is going to remain the same. And so the coordinates of this point are going to be -1, 0. And for this point, the coordinates are 0, -1. And what we are going to do in this unit circle is that we are going to draw a line from the origin up to any point on the circumference. So let's say if I draw this line from the origin up to this point like this, and let's say that the angle of this line from the x-axis is theta. So the point of intersection of the terminal side of this angle and of the circle is going to be this point over here. Let's suppose that this point is A, B. And now what I'm going to do, I'm going to find the relationship between A and B and theta. So I'm going to write A in terms of theta and B in terms of theta. So I'm finding the relationship between this angle and the point of intersection. So the x coordinate at this point is A, means that this point, if I drop a vertical line, this point is A. So the distance from the origin up to this point is also going to be A. And the y coordinate at this point is B. So this point over here is B. So this means that this distance over here is B, or I can say that this distance is B. And you can see that this is a right angle triangle. So I'm going to draw my 90-degree angle, which is going to be this. If I redraw this in a blue line, that would be much clearer. Now, since this is a right angle triangle, I can apply SOHCAHTOA over here. I can apply basic right angle triangle trigonometry over here. So let's apply these basic trigonometric functions: sine theta, cosine theta, and tangent of theta. We know that sine theta is opposite upon hypotenuse from this rule. The hypotenuse is always the opposite side to the 90 degrees. So this is going to be the hypotenuse, and the opposite side is the opposite side to the reference angle, which over here is theta. So this is going to be my opposite side, and the side left or the side adjacent to the angle is called the adjacent side. So sine theta is opposite upon hypotenuse, cosine theta is adjacent upon hypotenuse, so adjacent upon hypotenuse, and tangent of theta is opposite upon adjacent, so opposite upon adjacent. We know that the length of the opposite side is B, so in place of the opposite side I'm going to write B, and in place of the hypotenuse, you can see that the hypotenuse is from the origin up to the circumference of the circle. If the radius of this circle is 1, then this distance and this distance is going to be the same, because this is also the radius. So the length of the hypotenuse is 1. So in place of hypotenuse, I'm going to write 1. And B upon 1 is just B. So I get sine theta is equal to B. And for adjacent, the length of the adjacent is this A. So in place of adjacent, I'm going to write A, and the hypotenuse we know is 1. And A upon 1 is just A, so I get cosine theta is equal to A. And so tan theta opposite upon adjacent is going to be B upon A. So I get tan theta is equal to B upon A. So what I get from all of this is that this point of intersection A, B this point A over here is equal to cosine theta. So in place of A, I can write cosine theta. And in place of B, B is sine theta. So in place of B, I can write sine theta. So I have written A and B in terms of theta. So what this means is that for any angle theta, if theta was bigger, if I draw another circle over here, so if I draw a smaller triangle with a smaller angle theta, even then the points of intersection are going to be A comma B, meaning cosine theta comma sine theta. If I draw a bigger angle like this, so I would get a bigger triangle. Even then the points of intersection, this point is going to be cosine theta times sine theta. And if I draw a triangle in the negative x-axis or in the negative y-axis, then these points are also going to be cosine theta, sine theta, cosine theta, sine theta. So this means that for any point on the circle, the x coordinate is always going to be cosine theta and the y coordinate is always going to be sine theta. So I'll write this over here. The x coordinate is always cosine theta and the y coordinate is always sine theta for the unit circle. And in the next video, we'll be using this information to find the graphs of the sine function and the cosine function using this information.